What will I talk about today? First, some short introduction. Who am I, and who is Færch? Why I were using octoplant? How do we use octoplant? And the way we have structured our items inside octoplant. And lastly, a short summary of what I've been talked about today. My name is Brian. I'm working at Færch as a technical support manager. In the past, I had some other job description. The last one was production technical manager, which was responsible for all technical equipment inside our Holstebro factory. And this is production equipment and also facility. I am a marine and a technical engineer, and for um, 3 years ago, I took this diploma in technology and maintenance, which I will talk a bit about later on. And I've been at Færch since 2014. Who is Færch? Færch is a leading supplier of plastic trays, and we have now factories around the globe. In Holstebro, where I normally placed, we produce around just over 1,000 tons of extruded plastic each week. And we produce around 28 million trays per week also. Yeah. Færch is now located all over the world, mostly in Europe. Now we have over 25 factories. We also have two in the USA, and I think we also got one in India as well. What do we produce at Færch? I normally say that when you're going to the local supermarket and you are going for fresh meat, then the tray which this meat is placed inside, this tray is more likely produced by us in the Holstebro. But we also have other segments which we are producing too. We have ready meals, fresh meat, and the new big thing for us is dairy. One of the products we have we are really been known for is we are able to actually reuse plastic from a consumer. So trays which has been at the consumer before, we can take this to our plant in the Netherlands and wash it and make some new plastic pellets out of it and get it back to Holstebro and make new trays afterwards. So we call it closing the loop, and this product we call this for Evolve. This just so we have a little feeling of what is Færch. Why octoplant? As I told you just in the beginning, I took this diploma in maintenance, and this gave me a different way of thinking how to maintain system. It gave me a more, a critical way of thinking. This FMECA theory, failure mode effects and criticality analysis, and it is basically it's a bunch of questions you ask yourself. Let's say if a PLC breaks down, what happens? In my case, our cooling system stops. What does this mean? The whole factory stops in more than 50 or less than 15 minutes. And how to handle this? In this case, I have some questions to be answered. Do we have the latest PLC program? Where is it placed? Are we sure that this PLC program, which is inside the PLC, is also actually what we have a backup? Is this backup also containing the set points and the regulator parameters and so on? At the Holstebro, we also have 29 ABB robot cells, and in the past we had a technician which has done some manual backups, so he needed to enter each robot cell with his laptop and make this backup job. Now this is also done in octoplant with an automated job which backups the robot controller every 3 months, I think. And we also have a Prophecy iFix installation where we have 3 suppliers are working inside the same system but in different areas of the system. And they are making a lot of changes, and sometimes they are, sadly enough, overwriting each other's code, and this has also given us some difficulties or breakdowns in the past. Today we have one single developer PC. It's a virtual machine which we can remote connect, where all our software are located. This is also including octoplant. This is the client side of octoplant, which is located on this machine. In the past, it was a physical laptop. So if one technician have borrowed the laptop or used the laptop, then I was not able to access another software. This is possible now because it's a virtual machine. Now all our suppliers, they are forced to use this virtual PC when they are trying to access our network, and will make some changes, let's say in a PLC program or what it else could be. So if a supplier wants to access our network, they need to reach through Citrix, and then they can access our developer PC, which have octoplant installed on it, so it connects to the octoplant server, and then they are able to make changes. Some of our assets, they are different types of PLC, mostly Siemens PLCs. You can see we have different types of PLCs and also different kind of software for each type of PLC. We have OnRun, we have some Lense frequency converter, we have some actually a hard disk backup of our HMI control panel of some of our thermoform machines. We have different sensor parameters inside. We have label printer settings, and some of our assets are online, and it's quite easy to access them. But there's also some assets which are offline, and one of my main issues was how to access offline assets with our virtual PC. Because today, if I want to make a change in a Lense frequency converter as we have here, I will use this USB to serial converter, and then plug it into a USB port on the laptop. But this laptop was not able to actually share the USB port with the developer PC through RDP, not as I was aware. But we really needed to be able to do this because we have several equipment at the Holstebro, which are offline. And the way we have solved it is to use a software called USB Network Gate, which basically shares the local USB port on the laptop. So the developer PC will see this USB port as it was a local one, and then it's able to connect to our offline equipment. What we use octoplant mostly for is for backup and also a changelog. Now we have one system where all our parameter files, and including PLC programs, frequency converter, parameter files, and so on, are placed. And I know I guess it's quite hard to see here, but it's also just you can have a feeling that this is the changelog, so I can see each time there have been a change inside this asset. This is actually a PLC program. And in the bottom of the screen, I can see what was changed compared to the last version. This PLC is also configured with a automated backup job. And here you can see that the backup history, the job history, and a green icon is that it's successfully backed up. And we can also see that the program inside the PLC is the same as we have in octoplant. And from this screen, I'm also able to actually take out a backup and put it inside our working directory inside octoplant and work some more if I want to. In our iFix installation, we also use the octoplant now to keep a track of changes. A good thing is now that if a supplier is working on our iFix developer machine, they need to check out the asset, and then everybody else can see that now there's someone working inside our iFix installation. I can also see what have been changed and by who, and just to give you a feeling that in 2 years we have made 91 changes into our iFix installation, and this is done by different 3 different suppliers. And in the past this was not documented, and it was also difficult for us to roll back, because then we rely on our IT department that they have backed up our iFix systems, which they of course have, but now it's more easy for me to see what have been changed and by who, and quickly roll back if I want to. Then I'll talk a little about the structure, the way we have structured it in octoplant. We have divided it in a production department, which is in our case thermoforming, extruder, process and utility, and an iFix. So this is the top level. If you go to the thermoform contains what we call production lines. And if we expand one production line, we can see that it contains different machines, and a machine for us is a machine with its own CE marking. And this machine contains all the necessary parameter files. Let's say in this case it's a label printer file, it's a robot user setting, backup, robot backup, and so on. And this structure makes us able to quickly move the folders around and reflect the the real world, so to say, because we are sometimes moving around in our production lines. So one line can be fitted with another machine, so to say, and then it's more easy for us to move things around with this kind of structure in octoplant. So if I should give a short summary, for me, octoplant is a central place for us to save and find all our parameter files, because in the past it was in different Windows folders, somewhere on my local laptop, somewhere at a shared folder. Now we have one place to save it and to get our backup from. We also have this changelog function, so we can see what have been changed and who have changed it. It reduces the manual task by these automating backup jobs, in this case for the robots, but also for PLCs, running PLCs. We are able to check if a running PLC is the same as the backup we have. And the last point is we can now have a backup of PLC set points and PED parameters as well. And this is running automatically.